Servers fail, pods crash, entire availability zones suddenly just go dark. I mean, we've all lived through those infamous US East 1 outages, right? Honestly, it doesn't matter how elegant your code is or how wildly expensive your hardware is. If you're operating at scale, chaos is a guarantee. So, how do the best cloud architects and site reliability engineers handle this reality? Well, they don't try to stop it. They build systems that literally eat failure for breakfast. Welcome to this explainer. Today, we're tearing down the old myths of perfect infrastructure. We're going to take a deep dive into the architecture of modern reliability and really explore why designing for failure is the absolute foundational principle of being cloud native. All right, let's jump right in. Here's our roadmap for today. We'll quickly hit the inevitability of failure, shift into the cloud native mindset, break down some core resilience patterns, see auto-healing in action, and finally, wrap up with the operational benefits. Starting off with Section 1, the inevitability of failure. Look, modern platforms are incredibly complex beasts. We're talking distributed services, Kubernetes clusters spanning multiple regions, databases, third-party APIs, the whole shebang. At this massive scale, something is always failing. That's exactly why practices like chaos engineering exist in the first place. We basically have 4 main failure domains to worry about. First up, hardware fails. Disks degrade and servers just die. It happens. Second, networks fail. We constantly deal with latency, packet loss, or full-blown routing outages. Third, our own applications fail. Bugs, resource exhaustion, or sneaky memory leaks that cause sudden crashes. And finally, dependencies fail. Those external APIs and third-party services you rely so heavily on, they can and absolutely will go down. Any single one of these can trigger an outage. So if failure is literally everywhere, how do we handle it? That brings us to Section 2, the cloud-native mindset. Think back to traditional enterprise infrastructure. It was completely obsessed with preventing failures. We used to buy this incredibly expensive, top-tier hardware, just crossing our fingers and hoping to achieve zero downtime through sheer invulnerability. But cloud-native architectures, which are heavily driven by core SRE principles, take a radically different approach. They simply assume failures will happen. It's baked right into the DNA of the design. We have to stop asking, how do we make sure this never breaks? And start asking, what exactly happens when this inevitably breaks? It all boils down to this fundamental idea. We don't design systems that never fail. We design systems that survive failure. We aren't chasing perfection here. We are engineering resilience. The strongest cloud platforms out there don't avoid failure. They absorb it. Moving on to Section 3, core resilience patterns. Let's make sure we're all on the exact same page here. Resilience is the ability of a system to continue operating and recover automatically when inevitable failures occur. Notice that keyword automatically. This isn't about getting a blaring pager alert at 3 a.m. and manually SSHing in to reboot a server while you're half asleep. No way. This is about the system fixing itself before a human even realizes something went wrong. To pull off that kind of automatic recovery, modern architectures rely on a specific set of tools. Think of these as your engineering pillars. We use redundancy, running multiple instances to completely eliminate single points of failure. Auto-healing ensures that failed workloads are immediately replaced by the system. Then you've got load balancing, which shifts traffic instantly away from danger and distributes it only across healthy resources. Multi-zone deployments guarantee that even if an entire physical data center goes dark, your application survives without skipping a beat. And honestly, absolutely none of this works without observability. You have to detect issues early and act before there's a broader impact. Together, these elements form a rock-solid, unified strategy of automated recovery. Okay, Section 4, auto-healing in action. Let's step out of the theory for a minute and look at a live incident response. Imagine your users coming in, completely oblivious to your infrastructure. Their traffic hits a load balancer, which dynamically routes them across 3 different availability zones. Let's call them AZ1, AZ2, and AZ3. Inside each of those zones, we have node pools running our application pods. But suddenly, in AZ2, a pod crashes. Bam! A failure just happened. In an old-school, traditional setup, users hitting that pod would get a nasty error screen. But in a cloud-native system, it immediately kicks into a detection and recovery loop. The load balancer instantly stops sending traffic to the dead pod, rerouting it to the healthy pods in the other zones. Simultaneously, auto-healing activates down at the infrastructure layer to provision a brand new pod. Let's break down that exact timeline, especially in an environment like Kubernetes. Step 1. A pod crashes, maybe due to a bug or resource exhaustion. Step 2. Within seconds, automated health checks fail. The system's observability layer immediately recognizes the anomaly. Step 3. Kubernetes doesn't wait for human permission, it automatically creates a replacement pod to restore our desired state. Step 4. Traffic shifts to healthy instances while the new pod spins up. By the time the replacement is ready, it's just seamlessly added back to the load balancer's rotation. The failure occurred, the service survived, and most importantly, the users never noticed a thing.
Which brings us to Section 5, the operational benefits.
These complex engineering patterns directly translate into massive business value. Higher availability means your critical services actually stay up when the hardware underneath them is literally burning down. Faster recovery through automation drastically reduces downtime, which directly protects your revenue. Improved resilience means your systems can withstand real-world, unpredictable forces. Ultimately, all of this cascades down into a much better user experience. Reliable applications earn customer trust. And for the engineering teams, it means greater operational confidence. You finally stop fearing Friday deployments and overnight outages because you know the system is purposely designed to catch itself when it falls.
So, if you're out there designing cloud-native platforms, here are the core recommendations you need to take away. First, accept failure as a baseline design requirement. Honestly, it's a mindset shift before it's an engineering shift. Second, relentlessly implement redundancy. There should be 0 single points of failure in your critical path. Third, utilize automated health checks tied directly to auto-healing systems like Kubernetes. And finally, always deploy across multiple availability zones to contain the blast radius of any outages. You need to prepare for failure, detect it quickly, recover automatically, and deliver continuously.
I'll leave you with this final thought. Your systems, your dependencies, or your hardware will inevitably fail today. The question is, will your users even notice? By embracing these cloud-native principles, the answer can confidently be no. Thanks so much for joining me on this explainer, and happy building.